Dear students, I welcome you all to a new session on numerical. Let us begin with the statement of the numerical. A pair of Spur gear have 16 teeth and 18 teeth. A module 12.5 mm, an addendum 12.5 mm, and a pressure angle 14.5 degree. Prove that the gears have interference determine the number of teeth and the velocity ratio to avoid interference. This numerical was asked in VTU examination August 2001, then January 2005, then December 2010, recently July 2016. So it has appeared quite a few number of times in the VTU examination. Let's first analyze the statement of the problem. A pair of spur gears, that means there are two gears having teeth 16 and 18 teeth, a module 12.5 mm, an addendum 12.5 mm, and a pressure angle 14.5 degree. Prove that the gears have interference. Second, determine the number of teeth and the velocity ratio to avoid interference. So, number of teeth required for avoiding interference and velocity ratio to avoid interference. These are the parameters that we are going to find in this numerical. So we'll begin with the solution, giving or stating the given data. So solution, given data. So the given data are, to begin with, there is teeth equal to 16 and 18. Then there is module m is equal to 12.5 mm. Then there is addendum equal to 12.5 mm. Then phi is pressure angle 14.5 degree. So with these details, we shall now try to find the solution for the numerical. First, we'll write addendum of gear is given by AW, which is constant, into module. Now this is given as 12.5 and module is also given as 12.5. Therefore constant A equal to 1. We also know that gear ratio G is given by capital T by small t. So capital T is 18 divided by small t is 16. So if I take 18 divided by 16, it is 1.125. Now minimum number of teeth on gear to avoid interference is given by T is equal to 2AW divided by 1 plus 1 by G into 1 by G plus 2 into sine square phi. This whole term is under square root minus 1. So this is the equation for minimum number of teeth on gear to avoid interference. Now we need to find the value of T using all these parameters. So we have G value equal to 1.125, AW is known, phi is given as 14.5 degree. So using these data we'll now find the value of T. So it is, numerator is 2 into 1 divided by, so this is 1 plus 1 by 1.125 into 1 by 1.125 plus 2 into sine square 14.5 minus 1. So this is the substitution. Now we need to calculate the values. So I'll take square root of 1 plus, it is 1.125 inverse into 1.125 inverse plus 2 into sine 14.5 square is this much, is the under square root minus 1 is this much. So 2 divided by denominator is 25.81. So it is 25.81. So this is 25.81. Now what we have to note here is this value of 25.81 is more than the value of teeth on the gear, that is 18. So the required number of teeth is 25.81 and the one which is existing is 18. Since 18 is less than 25.81, it is evident that there is interference. So we'll write the conclusion. The given number of teeth, on gear is 18, as it is less than the calculated value interference exists. So hence proved. So this is the first part of the numerical. Prove that the gates have interference. Now we should find the number of teeth. Now if you closely observe 25.81, if we round it off to the next number, that it becomes 26. Now what happens if we select 26? Now the value of G is 1.125. So if I take the value of capital T equal to 26, then it will become 26 divided by 1.125. So this is 23.111 is the value of T. Since T cannot be decimal, it should be a whole number, we cannot consider 26 as evident from this calculation. So what is the solution? We need to go to the next number and select 27 and check whether 27 is suitable or not. So I will take 27 divided by denominator is G, so that I get the value of T. So 27 divided by 1.125 is comes out to be 24. So 24 is a whole number, so we can select 27 as the ideal number of teeth. So now select the number of teeth T is equal to 27. If 26 is selected, then what did we observe? We observed that the number of teeth on pinion becomes fractional. So we select the T value equal to 27. If we select T is equal to 27, then T is equal to capital T by G. This is nothing but 27 divided by 1.125, which comes out to be 24. So small t is 24. So minimum number of teeth on gear capital T is 27. Minimum number of teeth on pinion small t is 24. Hence velocity ratio, which is nothing but G, is equal to 1.125. This is what was asked in the numerical, is the velocity ratio to avoid interference, hence the solution is achieved. So the first part was to prove that gears have interference. That was proved by showing that the value of number of teeth to avoid interference is more than the one which is existing, which is 18, and the one which is required for avoiding interference is 25.81. So the first part was proved. Then determine the number of teeth. The number of teeth was determined by selective method, and finally the velocity ratio to avoid interference was to select the value of teeth as 27 and 24 to give the velocity ratio of 1.125. Hope you have understood the problem. Thank you for watching the video.